Hello everyone, my name is Sharma and in this video I'm going to demonstrate my task 4.3D from the embedded system SIT 210. In this task we had to design a system using Arduino that combines multiple inputs and output together. The main goal was to use a push button and ultrasonic sensor and a BS1750 light sensor along with three LEDs to perform different operations. Each sensor and component controls one LED or displays data on the serial monitor, and the system also performs timed actions automatically. For the hardware, I have used an Arduino Nano 33 IoT, a push button, an ultrasonic sensor, a BS1750 light sensor, three LEDs, and breadboard and some jumper wires, along with 220 ohm volt, 220 ohm resistors. The push button is used to toggle LED 1. The ultrasonic sensor measures the distance and controls LED 2 when something comes close. The BS1750 light sensor detects brightness and logs any significant changes. The LED 3 blinks automatically every second using a timer. All the sensor data and messages are displayed on the serial monitor. Now, let's talk about the circuit connection. The push button is connected to the digital pin 2 with the internal pull resistor connected to the ground railing or then on the grid. After that, the LED 1 is connected to pin number 5, LED 2 is connected to pin number 6, and LED 3 is connected to pin number 7 on the Arduino net. The ultrasonics trigger pin is connected to pin number 8 and the echo pin is connected to pin number 9. The VCC of the ultrasonic sensor is connected to the 5 volt on the Arduino Nano and the ground is connected to the ground railing turned on the headlight. The BS1750 light sensor is connected using the I2C interface, that is SDA and SCL pins. All the components are powered directly from the Arduino board, and the light sensor is connected with the 3.3 volts on the Arduino Nano. So now let's see how the code is working in this task. So firstly, we have included all the libraries which we will need in this task. After that, we have defined all the variables and the pin number. Like the button pin is on pin number 2, the LED one pin is on pin number 5, and similar, we have defined them all. After that, we have defined the global variables. After that, the ISR button. Here, the button, if we have a button interrupt, it will show button interrupt and LED one toggle. Then let's come to the setup section where we have initialized our serial monitor with the baud rate of 9600. Then when the serial monitor starts, it will print a message task 4.3D starting. Then we have set it up our all the pins for input, output, and input respectively. After that, we have our attach button interrupt. So we have defined it there. Then we have our initialization of BS1750 light sensor. If the BH1750 light sensor is initialized smoothly, it will print this message. And if not, it will print this message. After this condition is true, it will show this message. Setup complete. Then let's come to the loop. So here we are dealing with the timer interrupt, which will run each second. And here it's just deducting the last milliseconds, the last millisecond, and assigning its value and getting its value from current milli. So this is just current milli, the current time, the current millisecond, and last millisecond. And if that difference is greater than 1, the last millisecond value is equal to our 10 millisecond. Then this is the setup for LED 3, the timer interrupt, LED 3 toggle. Then this block is completed for ultrasonic sensor. Here we have set it up our pin to the right, and this will bring the ultrasonic sensor just the measure distance, and this is the condition for the LED state So if we bring our object in front of our ultrasonic sensor, and the distance is between 0 centimeter to 20 centimeter, the light will turn on, the ultrasonic condition met, leading to thermal. Similarly, this is for A1750 light sensor. So the lux reading is Z minus. It will give error reading is 1750, and this will only print measurable change of 5 lux. It will see the current lux value, the current brightness, and will come with the last brightness. And the base of on that basis, it will print brightness increased or brightness decreased, and then it will show us the current brightness. Less. Then the last brightness will get the value of less.
So now let's see how the system will work. So here you can see the task 4.3, the starting message, then initialize successfully, then setup complete. Then here we have the timer interrupt, which will go each second, and then we have the ultrasonic sensor distance, which is right now 29, and the current brightness level is, you can see it. Okay, now you can see it. It is 8.33. Then timer interrupt. Then again. So let me just show you. So this green LED is for the timer interrupt. This is our BS1750 light sensor. This is our Arduino Nano. This is our ultrasonic sensor. The ultrasonic sensor is connected with this LED, the yellow LED, and then we have the push button, which is connected with this red LED. If I press this button, this LED will glow up, and let me just so here you can see. Okay, I have to. Yes. So here you can see I'm pushing this button, and here you will be able to see the message for LED1 button interrupt, LED1 toggle. Similarly, if you see this light is blinking each second, it's also giving us the timer interrupt LED3 toggle. So let's come to our ultrasonic sensor. If I place my hand in front of this, it will turn on this light, this yellow light, and here you can see the message too. So here ultrasonic sensor distance 5 centimeter. It comes in our range of 20 centimeter. So the LED light is on. If I place my hand again, the light will turn off, turn on, turn off. You can see the readings here: 9 centimeter, 8 centimeter. Otherwise, it's showing 302 centimeter because that's facing that side. Now let me just move this. So now you will see the brightness increased 102 to 124, and when I put it down, brightness decreased from 124 to 100, then 100 to 36. If I fully cover this, the brightness, let me just show you, the brightness should decrease. Here you go, 30 to 8, and then 8 to 0, and now it's like this. So there's some light falling on this part. So again, the flux value changes from 0 to 22, and you can see my task is running perfectly. The timer interrupt, the ultrasonic interrupt, and the button interrupt, everything is running perfectly. Also my BS1750 light sensor is also printing the values, the change in value.
In conclusion, this task helped me understand how to use interrupts, sensors, and timer together on our Arduino board. It was a great experience to all the components working at the same time and responding instantly. Thank you for watching my demonstration video of task 4.3D. Thank you.